When a production engineer sets out to examine and judge the performance of a centre lathe, what are the main points he'll look for? One of the features he'll look for is the ability of the machine to take a cut smoothly and at speed on the toughest of materials. He'll look also for versatility. The lathe must be able to handle a wide range of turning operations as quickly as possible. This setup, with a hydraulic profiler and capstan attachment added to a standard chipmaster, vividly illustrates this point. And it rings. Above all, the production engineer will look for accuracy. Finished boring of this bush is typical of those operations where fine tolerances must be maintained. No lathe leaves our factory until it's proved itself capable of meeting these fine tolerances. And the purpose of this film is to show some of the many ways in which we ensure these standards of accuracy and combine them with a low capital cost. We specialize in lathes. We make, and always have made, nothing but lathes. And every one undergoes a series of rigorous checks throughout its entire process of manufacture. Continuous production methods ensure relatively low manufacturing and selling costs, to which is coupled an insistence on the highest possible accuracy. There are two main components most likely to interest the engineer. The first is the headstock. The second is the bed. A rigid bed with extremely accurate slideways is essential. Careful design ensures that the bed is rigid, and 100% inspection guarantees the accuracy of the slideways. Efficient production of an accurate bed requires an accurate casting, and the basis of a good casting is a good pattern, here made of aluminium for precision and durability. The hardened sand mold made from this pattern is sprayed with a graphite. The spirit carrier for the graphite is flashed off, leaving a hard skin on the sand which allows the casting to come away cleanly. The cores for the mold are made in separate units. Sea sand bonded with sodium silicate is forced into the core box from a sand reservoir into which air is blown at high pressure. Quick and accurate filling of the core boxes is followed by chemical hardening of the sand by injecting carbon dioxide gas. No heat is used, and it is because the cores are made separately that they can all be hardened by this CO2 method, which saves a great deal of time and money. Taken from their boxes, the hardened cores join the stock of different shapes waiting to be placed in position in the mold. Thus, the internal shape of the casting is gradually built up by the insertion of the cores. Having reached the right temperature, molten metal from the cupola is poured into ladles. The bed is cast in the inverted position, since this produces cleaner slideways at the base of the mold and more uniform hardness. Lastly, the cup through which the molten metal is poured is fitted to the mold. and the bed is cast. The fettled bed casting comes from the foundry ready for the first operation, milling. Tungsten carbide gang cutters completely machine the bedways in one pass, ready for hardening. The bed is hardened using high-frequency induction equipment to a hardness reading of 450 Brinell. The specially designed intensifier operating at a frequency of 400 kilocycles per second incorporates simultaneous water quench and insists in achieving consistent hardness with a minimum of distortion. After a stabilizing period, the beds pass to the grinding department. This unique bed grinding machine has been developed to machine 3 beds at a time. All machining operations are completed in one setting of the bed, including the bed form and the attachment faces for additional equipment such as profilers and taper turners. Random samples are checked for cracks with this special magnetic flux type crack detector. Thus we ensure beds of high precision and perfect surface finish. And so to the headstock, the heart of the lathe. It's in the headstock that the greatest possible precision must be achieved. To ensure this from the outset, the rough castings must be properly seasoned. When wanted, the casting is brought into the shop for shot blasting. A couple of minutes in this machine ensures that the surfaces of the casting are clean and removes any moulding sand from the critical surfaces. It also gives a good key for subsequent painting operations. In the fettling shop, grinding wheels and a variety of abrasive equipment are used to remove flashes and rough spots. Zinc chromate primer forms a good base for the paint. Then a knife-applied filler, followed by wet rubbing down, produces a good and clean surface. A sealing coat, inside and out, and they're ready to move off for milling. The headstock castings are milled on a fully automatic programming milling machine. All side faces are roughed and finished at one setting, and once the program is set, the complete cycle of operations is carried out automatically. This machine is typical of the equipment used to achieve accuracy allied to money-saving production techniques. The bearing housing bores are now machined on double-ended multi-spindle fine boring machines specially designed at Colchester. 10th tolerances are maintained and all bores finished in one cycle. Every headstock housing is carefully inspected for ovality, taper and diameter before being passed to the assembly department. With the housing completed, we move next to the headstock gears. Here again, in order to combine accuracy with economy, the latest production techniques are employed. This 6-spindle auto ensures perfect concentricity of blanks because the complete machining is carried out in one clamping. This particular component, a gear blank, is produced from high tensile steel in under 3 minutes, typical of the high production techniques employed in our turning department. The teeth are initially cut on modern gear hobbing machines, enabling the use of two-start hobs and climb cutting techniques. Accuracy at this stage of manufacture is vital, as any errors cannot be fully corrected by subsequent machining operations. After hobbing, the gears are semi-finished by shaving. As the term implies, a very small amount of material is removed from the tooth blank by this process, the object being to improve concentricity, tooth form and finish. After shaving, the teeth of the gear are hardened by an underwater high-frequency induction process. The gear to be hardened is mounted on a mandrel supported in half bearings. When the gear is set on the machine, the water tank is raised by push-button control into the working position. The workpiece is submerged and the cycle is controlled by limit switches. The gear is indexed automatically and each tooth is hardened individually. By this method of induction hardening, the distortion normally associated with other forms of gear hardening is eliminated, in that the hardness pattern follows the contour of the tooth. After hardening, the gears are finished by honing. The action of the abrasive impregnated gear-like tool rotated in tight mesh with the hardened workpiece is to provide any slight correction that is needed to the form of the teeth. Spot checks are carried out in the standards room to ensure consistent control of involute and lead. In checking the involute, the stylus traverses along the profile of the gear, and in the lead, the length of the tooth. A graphical recording is obtained and checked against permitted limits. On another machine, the test gear is run against a precision master, and a composite check for concentricity, pitch, and tooth spacing is made. Once again, a graphical recording is made. Passing from the headstock gears, let us now look at some of the processes involved in the manufacture of the spindle. After the rough forging has been bored and the two clamping positions accurately turned, this machine faces both ends of the spindle, cones them, and rough tapers the nose end. The machine is double-ended, and the tools not only rotate and feed in longitudinally, but also feed transversely. Once the facing is finished, the tool changes speed and then roughs out the taper in the nose end. The tool at the other end faces the bore, cones it, and gives it a good machine surface for holding in the next machine. The spindle then passes to this modern copy-turning lathe, which profiles the whole length of the spindle. A series of roughing cuts are made before the final finishing cuts. Tools from the overhead side machine the various undercuts for grinding, which is the next operation. The spindle is ground all over. Very fine tolerances are maintained, the bearing seatings in particular being controlled to a tolerance of 1/10 of a thou. Meticulous care is taken with the spindles, and every one undergoes stringent tests for concentricity and ovality as well as for size. The internal and external tapers of the spindle are checked with bluing gauges. The bluing must show the full length of the gauge on both internal and external tapers. With all the care and production skill that goes into the making of the spindle, however, it is in the spindle bearings that precision reaches its peak. Colchester Lathes are fitted with Gamay taper roller bearings, the most accurate bearings in the world, and designed specifically for machine tool spindles. The very fine tolerances involved require special manufacturing techniques. To ensure these fine tolerances, especial care must be taken at all stages in checking the components. The bearing rings are subjected to 100% inspection. Here, finished inner rings are being checked by air gauge to within 2 microns for roundness and taper, and the sizing of the bore is between nominal and +5 microns. The rollers pass through many inspection operations, starting with an ocular check for surface defects. This is followed by a series of extremely precise dimensional checks. Here, rollers are being angle checked and segregated into groups, which are later matched with inner and outer rings which have been similarly controlled. These processes ensure the geometrical accuracy of the assembled bearing. Finally, the diameter, roundness and form of the thrust face of the rollers is checked on an electronically controlled calibrating instrument capable of revealing deviations as small as 4/millionths of an inch. In this way, consistency of size and form is achieved. In each bearing, the dimensions of the rollers do not differ by more than 10/millionths of an inch. Having been segregated into specified size groups, matched sets of rollers are then assembled into the cage, ready for assembly of the complete bearing. These standards of precision, coupled to its unique design, are the key to the unrivaled accuracy of the Gamay bearing. A perfect spindle with perfect bearings and mounted on a perfect seating. Herein lies the secret of the accuracy of Colchester Lathes. Now the lathe is ready to cut its test piece. It must prove itself capable of turning this within a deviation from true roundness of no more than 1/10 of a thou. The test piece is turned, and an identifying label is fixed to it, ready for its check on the tally rod, a machine designed expressly for the purpose of measuring deviations from a true circle. The test piece is mounted on the table and centered. As soon as these adjustments are made and the test piece is centralized to the axis of the spindle, The out of roundness is reproduced on a circular graph by means of an electric pencil. Magnification can be varied. Here it's 5,000 times, so that each space between the lines is only 20 millionths of an inch. Inspection completed, the test piece is found to be accurate to within 30 millionths of an inch, 3 times better than specification. And this is only one of the many checks made to ensure the accuracy of every Colchester lathe before it leaves the factory. Let us now consider versatility. A typical attachment is this taper turner. Fitting this unit in no way interferes with the normal operation of the lathe. A telescopic cross-slide screw enables cuts to be made from the cross-slide handwheel. This hydraulic profiling attachment enables the standard lathe to be converted simply and cheaply to a copying lathe. Models with either 60-degree or 90-degree slides are available. Threads can be cut at speeds up to 5 times faster than normal with the Aingest rapid threading unit. It will thread tight to a shoulder at maximum speed. Blind bores need no undercut. It's impossible to engage the half nut in the wrong position. Versatility is further enhanced by this capstan attachment. The complete unit can be fitted in place of the tailstock in a matter of minutes. And provision is made on every lathe leaving the factory for these, and the many other items in the comprehensive Colchester range to be added to the machine whenever the customer desires. Turned from the solid bar in 45 seconds. Buyers are naturally interested in after-sales service, and based upon our headquarters at Colchester, we maintain a fleet of well-equipped vans ready to go anywhere at the shortest notice to deal with urgent service calls. And through a network of agents conveniently sited all over the British Isles, we keep in close touch with our friends and customers. A full range of spare parts and accessories is always kept in stock, and we pride ourselves in running an SOS service in a crisis. Any item in our catalogue, fully protected against corrosion, will be on its way from our works in a matter of hours from receiving the call. This service applies not only to the United Kingdom, for through our sales and service units in foreign countries, we're in constant touch with our customers throughout the world, to whom additional equipment or spare parts can be sent with the utmost dispatch. Our range of lathes is designed to meet the many and varied requirements of industry. From the revolutionary 5-inch chipmaster, on which we introduced infinitely variable spindle speeds up to 3,000 RPM, to the 6-inch student with specially built-in safety features which have earned it an enviable reputation as a training or production machine. And on to the 6.5-inch master, a larger edition of the student and embodying all the well-tried features and the versatility of the student. To the famous 7.5-inch Triumph heavy-duty lathe, which is equally at home as a tool room or a production machine. finally to our largest, the 8.5-inch all-geared Mascot, renowned all over the world for its rugged dependability under the most arduous conditions. It is by high precision engineering, allied to the money-saving continuous production techniques that we've shown you in this film, that this range of machines enables us to make good our boast that the world turns on Colchester Lathe.